Hi everybody, in this video I'm going to introduce to you some concepts that are related to confidence intervals. And then afterwards, if it doesn't fit on this video, I'll definitely make a new video that's doing some exercises on how to actually calculate a confidence interval for a population mean. So an example of that I mentioned in class was, let's say we want to know um, on average how many bowls of bran a week the average senior citizen eats. Well, we can't ask every senior citizen out there how much bran they eat in a week because that's almost impossible of a task. So what we would do is we would ask a sample of senior citizens how many bowls of bran they eat in a week, and then use that to estimate how much the entire population might eat. Okay, so in order to do a confidence interval, one of the things we have to be able to do is we have to find a point estimate and a margin of error, which I'll explain. And then after that, we can construct a confidence interval that gives us an idea of what the possible population mean, or mu, that u with a little tail on it, is. So a point estimate is just a single value that estimates a population parameter. And when we're talking about a population mean, that point estimate that we use is the sample mean, which we call x bar. So basically, we use a sample mean as a starting point to basically figure out the the average for an entire population. Okay, so we use the sample statistic of how much bran on average seniors eat, and then we generalize it to all senior citizens. So here's an example. A social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of the number of friends for 40 users of the website. Find the point estimate of the population mean mu. Okay, so basically, if a point estimate for the population mean is just the sample mean. So we've got all these data points here, and average is just simply add all the points up divided by how many there are, which is 40. Okay, well, I'm not going to type into the calculator because that's tedious. But if we were to do that, basically we see that the average for the sample is 130.8. Okay, so we have a sample average of 130.8 friends. Okay, so that's the average number of friends for the sample. So a confidence interval then gives us a range based on that sample statistic, that sample average, of what the population average could be. Okay, so this interval, for example, hypothetical, of course, because we haven't done any math yet, basically says that the real population average for all social network users, like in terms of how many friends they have, is somewhere between a low of 115.1 and a high of 146.5. So I will show you in the calculator for sure how to actually come about getting those numbers. And it's actually not a hard process. And this interval that you estimate depends on how confident you want to be in your population mean estimate. Okay, so for example, we could say that we're 90% sure that the population mean is between x and y, or we could be even more confident. Maybe we want to know with 95% confidence. Or perhaps, we're talking like if you work for the medical industry and we want to see how effective a particular medication is, we might want to be 99% confident on how effective that medication is overall. So this level of confidence is basically a probability that the interval that you create actually contains the population average, or the mu. Okay, and in this case, it will depend on the probability level that you're setting. Okay, if we're saying 90% versus 95% or 99%, we can't ever do 100%. Okay. Um, The confidence level is the area underneath the standard normal curve, okay, between two critical values. And I'll talk about how you get that. Okay, so when we're doing a confidence interval, we're essentially looking at the center of this normal curve, okay, as opposed to the tails. So, as I kind of said already, if the level of confidence is 90%, that means we are 90% sure that the confidence interval we made contains the actual population mean. Okay, which that means we're 90% sure that the confidence interval contains mu. That also means that there's a 10% chance that it does not. When we deal with confidence intervals for a mean, we're going to use what's called the t-distribution. And basically, the t-distribution is basically an approximate normal distribution. Okay, the t-statistic formula itself is given on this slide as the sample mean minus the hypothesized mu, or the hypothesized population mean, and that will be divided by the sample standard deviation over the square root of the sample size. Now, no need to memorize this formula. The calculator will actually take care of all of this, so don't worry about having to calculate t by hand. One of the things that's basically implied with the t-distribution is that basically it's approximately normal, okay? And essentially it will depend on your sample size, okay? So the t-distribution is still going to look like a bell curve, okay? And the center will still be in the middle, just like the normal curve. But the t-distribution will change depending on your sample size, okay? So when you're using a t-table, for example, the critical value you are trying to find is going to be based on sample size. We use a term called degrees of freedom basically to figure out which type of t-curve we're using. And in the case of one population mean, the degrees of freedom is just the sample size minus 1, which is not hard to calculate. The area under the curve is still going to be equal to 1. The difference is that the t-distribution changes and becomes more normal as you have more in your sample size. Okay, so as your sample size goes up, the more normal the curve itself actually looks. Okay. So if we wanted to find a critical value for a 95% confidence interval, and we have a sample size of 15 people, okay, we can refer to the t-table on UB Learns, and just so I don't have to change slides, I'll just show you the excerpt of what this t-table looks like, okay? So first thing is, let's get the degrees of freedom, because that's what it's labeled on our t-table, okay? So degrees of freedom is sample size minus 1. Well, if sample size is 15, take 1 away is obviously 14. So we're going to look at 14 degrees of freedom, and at the top row where it says level of confidence, we're just going to read across to 95%, which as a decimal is 0.95. Okay, where those two intersect is your critical value, okay, which is 2.145. Now the nice thing is you won't have to do that when you're using technology. So when you're doing a confidence interval, it basically will look up the critical value for you and just plug it into the respective formula. So basically 95% of the area under this t-distribution with 14 degrees of freedom basically lies between 2.145 standard deviations from the mean, okay, above and below. So the formula then for a confidence interval is basically the sample mean plus and minus the margin of error, okay? Margin of error is calculated here as the critical value times the standard deviation over the square root of the sample size, but the calculator will take care of that for you. So if you're ever trying to figure out margin of error, it's basically the difference between the sample mean and one of your two endpoints, either the highest value of the confidence interval or the lowest. So step by step wise, when you're doing a confidence interval, if you were doing it by hand, okay, you need to know the sample size, which is n. You need to know the sample average, or x bar, and you need to know the standard deviation for that sample. Okay, so that's the key there. It's a sample standard deviation. And one of the things I should have mentioned earlier was that the t-distribution, basically the reason why there's so many variations of that distribution is because the t-distribution is based off of this, the sample standard deviation here. We use the t-distribution when we don't know the population standard deviation, which we had called sigma in the last chapter. We typically don't know that in real life, so that's why we use the sample standard deviation, and that's why we switch to a new distribution, which is t. The degrees of freedom is just n minus 1. Okay. And if you're doing it by hand, you'd find the margin of error and basically add and subtract that from the confidence, from the sample mean. And that will give you your actual confidence interval. So I'm going to stop the tape on this one, and I'm going to switch to a new tape just so I can show you how to use, how to do a confidence interval in a calculator.